In this question we are given function f and its derivatives, the relationship between the previous derivative and the following derivative and the first two derivatives at 0. And in this question we need to show that the first four non-zero terms of the Maclaurin series for f are those, and then write the general term as well. So we have the first two derivatives. Let's look at the following derivatives after that. The second derivative at 0 is actually negative 1 times the first derivative at 0, which gives us negative 1. Second derivative, this next derivative is 0. Third derivative is, in this case, it's negative 2 times f double prime of 0, which gives us negative 2 times negative 1 is 2. And then the fourth derivative at 0 is equal to negative 3 times f third derivative at 0, which gives us negative 3 times 2, which gives us negative 6. So the first four elements, this element will be 0. The next element will be the derivative f of 0 plus f prime of 0 times x over 1 factorial plus f double prime at 0 times x squared over 2 factorial plus f the third derivative at 0 x cubed over 3 factorial, and then the fourth derivative at 0 x to the fourth power over 4 factorial. And this is 0, so this is the first four non-zero elements will be those, and let's just plug in the values. This is equal to f prime of 0 is 1, x over 1 factorial, so x plus the second derivative at 0 is negative 1 times x squared over 2 factorial plus the third derivative is 2 x cubed over 3 factorial over 6, and then plus the fourth derivative is negative 6 times x to the fourth power over 4 factorial is 24. So simplifying this gives us exactly what we are being asked, x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4. And so as you can see, the general element will be x to the nth power over n, and then the sign will be alternating with opposite to this power, so it's negative 1 to the power n plus 1, so this is a general term. So in this question we are being asked whether the series that we just determined in part A converges absolutely, converges conditionally, or diverges at x equal to 1. And so when x equal to 1, that series turns into the summation from n equal to 1 to infinity, negative 1 to the power n plus 1 over n, and then x turns into x to any power turns into 1. And so we can recognize this as harmonic series with alternating signs, so it doesn't converge absolutely, but it converges conditionally because this term is decreasing in magnitude towards 0, and so the series converges conditionally. So this is our answer here. So in this question we need to integrate the first four non-zero terms, find what g of x is, and then also find the general term of this series. So the first four terms, integral from 0 to x f of t dt, is equal to, we just integrate from 0 to x the first four terms and the general terms that we had. And so those four terms is t minus t squared over 2 plus t cubed over 3 minus t to the fourth power over 4 plus and so on, plus negative 1 to the power n plus 1 t to the power n over n plus and so on dt. So let's integrate those terms. This will be the first term, t squared over 2 minus t cubed over 3 and 2 plus t to the fourth power over 4 and 3 minus t to the fifth power over 5 and 4 plus and so on, plus negative 1 to the power n plus 1 t to the power n plus 1 over n plus 1 times n plus and so on, and then we plug in here values x and 0. So you can see that 0 will give us zeros, and then when we plug in x, we get x squared over 2 minus x cubed over 6 plus x to the fourth over 12 minus x to the fifth over 20. Those are the first four terms, and then the general term is this one, negative 1 to the power n plus 1 x to the power n plus 1 divided by n plus 1 and times n. So this is our general term. So these are the first four non-zero terms, and this is a general term. Here we are given that p sub n represents the nth degree Taylor polynomial of the function g that we just defined in part C. And we need to prove that that approximation for the first four elements approximates the function with a precision which is less than 1 over 500. And so for the alternating series, the error bound can be bounded by the first unused term. So the first unused term here was negative 1 to the power of 4 plus 1 times x to the power n plus 1 over n plus 1 times n. And so we need to plug in n equal to 4 in here. And then x equal to 1/2. And so we take the absolute value, we will get that p4 of 1/2 minus g of 1/2 is less than or equal than the absolute value of negative 1 to the fifth power negative 1 times 1/2 to the fifth power divided by, this is 5 times 4, which is 20. And this is equal to, negative 1 doesn't matter because it's absolute term, 1 over 2 to the fifth power is 1 over 32 times 1 over 20. So this is equal to 1 over 640, which is less than 1 over 500. So this completes the proof here. Thank you, and I will see you in the next video.